Imagine for a moment you're walking down the street on a starry night and, suddenly, a strange light crosses the sky. Your heart races. Could it be? Could it have finally happened? Are we not alone in the universe? This question that has sparked our imagination for millennia is no longer just science fiction. At this very moment, scientists around the world are using humanity's most advanced technologies to answer the deepest question we've ever asked. Does intelligent life exist beyond Earth? Today, cosmic explorers, we're going to dive into our species' most fascinating scientific quest, the search for alien civilizations. I'll reveal to you how scientists calculate the chances of finding intelligent life in the universe, the mysterious signals we've already picked up from space, and why some of the world's greatest scientists believe contact might be closer than we imagine. And prepare for the most impactful moment of this video. I'll show you how a simple mathematical equation can predict how many alien civilizations exist in our own galaxy right now. Welcome to Cosmic Frontiers. I'm your guide on this incredible journey through the mysteries of the cosmos, and we're building together a community passionate about the universe, heading towards our first 1,000 cosmic explorers. The search for extraterrestrial life began long before modern telescopes and spacecraft. Ever since humans first looked up at the sky, we've wondered if those bright dots could harbor other worlds, other forms of life. But it was only in the 20th century that this search became truly scientific. Everything changed in 1961, when a young astronomer named Frank Drake organized the first scientific conference on the search for extraterrestrial intelligence. Drake faced a problem: how to calculate the chances of finding alien civilizations when we knew practically nothing about them. His solution was ingenious and elegant. He created an equation that would become famous worldwide. The Drake equation is like a cosmic recipe for calculating how many communicating civilizations might exist in our galaxy. Imagine you're trying to find out how many pizza places there are in your city. You'd start by asking, how many streets are there? How many of those streets have businesses? How many businesses become restaurants? And how many restaurants specialize in pizza? The Drake equation works similarly, but on a galactic scale. The equation starts with something we know well: the rate of star formation in the Milky Way. Our galaxy produces about one new star per year. Imagine a gigantic cosmic factory, working non-stop for billions of years. Next, we need to know what fraction of those stars have planets. When Drake proposed his equation, we didn't know of any planets outside the solar system. Today, we've discovered more than 5,000 exoplanets, and we know that practically all stars have at least one planet orbiting them. The next step is to determine how many of these planets are in the habitable zone, that region around a star, where water can exist in liquid form. It's like looking for apartments in a city. It's not enough for buildings to exist. They need to be in the right neighborhood, with the proper infrastructure. In space, this means being neither too close to the star, where water would boil, nor too far, where it would freeze. Here we come to one of the most fascinating parts of the equation. What fraction of habitable planets actually develop life? And even more intriguing, what fraction of that life evolves into intelligence? These are the big unknowns that keep scientists awake at night. On Earth, life emerged relatively quickly after the planet's formation, but it took billions of years to develop intelligence. Are we exceptionally lucky, or do we follow a universal pattern? The final part of the equation considers how long a civilization can communicate before it goes extinct. This is perhaps the most astonishingly uncertain variable of all. Our own technological civilization is only about 100 years old, a blink of an eye in cosmic terms. Will we be able to survive for 1,000 years, 1,000,000, or will we destroy ourselves before then? Depending on the values we plug into the Drake equation, we can get results ranging from "we are unique in the galaxy" to "there are millions of civilizations out there." This enormous uncertainty doesn't make the equation useless. On the contrary, it shows us exactly where we need to focus our scientific research. And that's exactly what scientists did. If alien civilizations exist and are technologically advanced, they probably use radio waves to communicate, just like us. In 1960, Frank Drake pointed a radio telescope at two nearby stars and started listening. Thus was born the SETI project, Search for Extraterrestrial Intelligence. Imagine the thrill of being a SETI radio astronomer. You spend hours, days, months analyzing signals from space, most of them just natural cosmic noise. But then, suddenly, something different appears in your data. have we finally found evidence of extraterrestrial intelligence. This happened dramatically in 1977, when astronomer Jerry Emmon detected a signal so strong and unusual that he wrote, "Wow," in the margin of the printed data. The signal lasted exactly 72 seconds, came from the direction of the constellation Sagittarius, and had all the characteristics we would expect from an artificial transmission, but it was never detected again, despite decades of attempts. The WOW signal remains one of astronomy's greatest mysteries. More recently, in 2019, scientists detected repetitive signals coming from the direction of the closest star to the Sun, Proxima Centauri. For months, these signals appeared only when telescopes pointed to that specific region of the sky. The scientific community was abuzz. Could it finally be the evidence we were looking for? After meticulous analysis, it was discovered that the signals came from human interference, probably from some electronic equipment on Earth. But the episode showed how close we are to having the technology needed to detect genuine signals. The SETI project has evolved dramatically since its early days. Today, we use artificial intelligence to analyze massive amounts of data, looking for patterns that could indicate an artificial origin. It's like having millions of digital detectives working 24 hours a day, each specialized in recognizing signatures of alien technology. But the search for extraterrestrial life is not limited to radio signals. A silent revolution is happening in astronomy. The discovery of exoplanets. When I was a child, we only knew 9 planets in the universe, those in our solar system. Today, we've discovered thousands of worlds orbiting other stars, and some of them are surprisingly similar to Earth. The Kepler Space Telescope, launched in 2009, completely changed our perspective on planets. It discovered that Earth-sized planets are incredibly common in the galaxy. It estimated that there are billions of rocky planets in the habitable zone in the Milky Way alone. This means that the basic ingredients for life as we know it, liquid water, moderate temperatures, atmosphere, may be much more abundant than we imagined. Some of these exoplanets are genuinely fascinating. Kepler 452b, nicknamed Earth's cousin, orbits a Sun-like star in a perfect habitable zone. TOI 715b was recently discovered in a conservative habitable zone, where conditions for liquid water are even more favorable. And Proxima Centauri, B, the closest exoplanet to us, is only 4.2 light-years away, practically our cosmic neighbor. But discovering a habitable planet is just the first step. How do we know if it actually harbors life? The answer lies in analyzing its atmospheres. When a planet passes in front of its star, the starlight passes through the planetary atmosphere before reaching us. Different gases absorb different wavelengths of light, creating a unique chemical fingerprint. The James Webb Space Telescope, launched in 2021, is revolutionizing this area. It can detect water vapor, oxygen, methane, and other gases that could indicate life. Imagine the thrill of analyzing an exoplanet's atmosphere and finding a combination of gases that could only exist if life were producing them. It would be like finding footprints on a deserted beach, undeniable evidence that something was there. Some scientists believe we are only 1 or 2 decades away from making this revolutionary discovery. Dr. Sarah Seeger, from MIT, one of the world's leading experts on exoplanets, states that finding signs of life in exoplanet atmospheres is not only possible, but probable within our generation. But here we come to a fascinating paradox that we've already explored in another video on our channel. If the universe is full of habitable planets, and if life is common, where are all the aliens? Why don't we see obvious evidence of advanced civilizations? This is the famous Fermi Paradox, which remains one of the most intriguing questions in modern science. There are dozens of possible solutions to this paradox. Perhaps advanced civilizations prefer to communicate using technologies we don't yet know. Perhaps they are deliberately avoiding contact with us, a kind of cosmic prime directive. Or perhaps intelligent life is much rarer than we expect, and we are one of the few technological civilizations in the galaxy. One particularly intriguing possibility is that we are looking in the wrong place or in the wrong way. Civilizations millions of years more advanced than us could use technologies so sophisticated that their activities would be indistinguishable from natural phenomena to us. It would be like an ant trying to detect human communications via the internet. It simply doesn't have the concepts or instruments needed. But perhaps the deepest explanation is temporal. The universe is 13.8 billion years old. but conditions for complex life only became favorable in the last few billion years. Civilizations can arise and disappear on timescales that make contact extremely unlikely. Two civilizations could exist in the same star system, separated by only 1 million years, and would never know of each other's existence. The search for extraterrestrial life also forces us to confront profound philosophical questions about our own existence. If we discover microbial life on Mars or Jupiter's moons, that would prove that life is not unique to Earth. If we detect signs of an advanced civilization, that would fundamentally change our perspective on our place in the cosmos. Carl Sagan, one of the greatest science communicators of all time, once said that absence of evidence is not evidence of absence. We have only seriously begun to search for extraterrestrial life in the last few decades. In cosmic terms, it's as if we dipped a cup of water into the ocean and concluded there are no fish because we didn't find any in the cup. Technology is advancing exponentially. In the coming years, we will have even more powerful telescopes, more sophisticated artificial intelligence algorithms, and detection methods we can't even imagine today. The Breakthrough Listen project is analyzing 1 million nearby stars. The square-kilometer array, when completed, will be the most sensitive radio telescope ever built, and future missions may even send probes to nearby star systems. Some scientists believe that the discovery of extraterrestrial life, whether microbial or intelligent, is inevitable. Dr. Jill Tarter, who inspired Jodie Foster's character in the movie Contact, dedicated her entire career to SETI and remains optimistic. She argues that we are living in the first moment in human history when we truly have the tools to answer the question about our cosmic loneliness. Others are more cautious. Astronomer Frank Tipler argues that truly advanced civilizations would have already spread throughout the entire galaxy, and since we see no evidence of this, we are probably unique. It's a fascinating debate that combines rigorous science with deep philosophical speculation. Regardless of when or if we find extraterrestrial life, the search itself has already transformed our understanding of the universe. We've discovered that planets are common, that the ingredients for life are scattered throughout the cosmos, and that our galaxy is a much more dynamic and interesting place than we imagined. The search has also taught us cosmic humility. We are a young species on a small planet orbiting a common star in a typical galaxy. If there are other civilizations out there, some may be millions or billions of years older than us, what could we learn from them? How did they solve problems we still face, such as climate change, resource scarcity, or social conflicts? But perhaps the most important lesson is about ourselves. The search for extraterrestrial life forces us to define what it means to be alive, to be intelligent, to be conscious. It makes us value the rarity and preciousness of life on Earth. If we are unique, that gives us an extraordinary cosmic responsibility. If we are not unique, that connects us to a galactic community we are only beginning to imagine. So, cosmic explorers, here are the 3 most fascinating points from our journey today. First, the Drake equation shows us that, mathematically, it's almost impossible for us to be alone in a galaxy with hundreds of billions of stars. Second, we already have the technology to detect signals from alien civilizations, and we are rapidly improving that capability. And third, the discovery of thousands of exoplanets proves that habitable worlds are common, making extraterrestrial life not just possible, but probable. The search for extraterrestrial life is fundamentally a quest to understand our place in the universe. We are children of the stars, made of the same elements forged in the heart of ancient suns. Our curiosity about alien life is, in essence, curiosity about ourselves and about the cosmos that created us. Cosmic explorers, I want to know, if tomorrow scientists announced the discovery of signals from an alien civilization, what would be the first question you would want us to ask them? Leave your answers in the comments. I love reading your reflections, and they always inspire me for the next videos. And speaking of upcoming videos, what mystery of the universe do you want me to talk about next week? Black holes, dark energy, time travel? Leave your suggestions in the comments. We are on an incredible journey towards 1,000 cosmic explorers. If this video expanded your perspective on our place in the universe and sparked your curiosity about extraterrestrial life, join our crew by clicking subscribe. Like this video if it made you look at the night sky with new eyes, and share it with someone who is also fascinated by the mysteries of the cosmos. Next week, we'll explore another phenomenon that challenges our understanding of reality. Until then, keep looking at the stars and wondering, is someone out there looking back at us?